Welcome to the story of adenosine deaminase and how she made adenosine's night one to remember. This is adenosine. Adenosine is a purine nucleoside made up of an adenine molecule attached to a ribose molecule. Adenosine also serves a variety of functions in the body. It's an important modulator of neuronal plasticity, learning and memory, motor function, feeding, control of sleep, and aging. If the amine group on carbon 6 is changed to a hydroxyl group, then adenosine is converted into inosine and ammonia. This process is catalyzed by adenosine deaminase, or ADA. ADA is a monomeric enzyme with 363 amino acid residues. If people end up with ADA deficiency, that can lead to severe combined immunodeficiency disease, which leads to repeated infections and can be fatal. This is also adenosine. Tonight, a super important party is happening, and adenosine really wants to go. The trouble is, she just can't figure out what to wear. Adenosine looks around her room and tries on a hat that she sees lying out. No, that doesn't work at all. Next, adenosine tries on a jacket. That also doesn't work. Frustrated and fed up, adenosine heads to the best salon in town, the active site. She walks into the salon and looks around. Suddenly, adenosine deaminase comes out from the back. Please help me. Of course, dearie. What do you need help with? There's a super important party tonight, and I can't go looking like this, but I don't know what to do. I've tried everything. I know just a thing. You'll be looking perfect in no time. All I need to do is eliminate your amine group and replace it with a hydroxyl group, and you'll be looking right as rain. ADA uses her zinc cofactor to activate her water molecule. Now that she's ready to do the reaction, she uses several amino acid residues to hold adenosine in place while she replaces adenosine's amine hiking shoes with new hydroxyl high heels. This is wonderful! Now I'm ready for the party. With my new hydroxyl shoes, I feel like a whole new person. From this moment on, I want to be known as inosine. It just feels right. Of course you do. You look just like an inosine. Have a wonderful night at the party. Let's take a closer look at this process. This is what ADA actually looks like. And here's the true structure of inosine. Highlighted in yellow is the structural change that has occurred from adenosine to inosine. To make things easier, let's also simplify the diagram of ADA until we only see the relevant components for this reaction. When adenosine deaminase agreed to help adenosine look perfect for the party, she knew that the solution would be to turn adenosine into inosine. This is ADA's job, so she was the perfect person to go to. Adenosine binds to ADA's active site. The active site is oblong and deep, so the entire nucleoside fits within it, with the ribose group closer to the opening of the active site. The zinc molecule coordinates the 5 amino acid residues that can be seen around it, and also protonates and activates the water molecule. The oxygen attacks carbon 6 on adenosine, forming a temporary tetrahedral intermediate. This intermediate is stereospecific, with oxygen always attacking from the back due to steric hindrance in the front. This intermediate is also unstable due to the possibility that the amine group is in an unfavorable hydrophobic environment. So quickly after the intermediate forms, the amine group protonates and leaves, becoming ammonia, and the hydroxyl group becomes a double bond oxygen on carbon 6. This reaction is irreversible, which means that now inosine has found her perfect dancing shoes. She's never going to take them off. At the end of the night, inosine comes home from the party so happy. It was exactly what she needed, and she would never have been able to go if it wasn't for adenosine deaminase. The end.